Hi guys, I hope you're good since last video. This video is for the people who would say while using Kubernetes, but I need to have this and that installed before running my pod container. But I need my container image to be lighter and get something that would be taking care of all of those installs. I need those configs to live alongside my pod. I need to monitor my pod for performance evaluation and security reasons. In this video, we are going to see a fascinating concept called Init containers and Sidecar containers. We are going to use easy to understand abstracted examples. After, it is up to you to reveal your creative sense. Sometimes you deploy a VM on AWS but want a script to run before to prepare the instance and have it ready to receive your AI application. In Kubernetes, you can do something like that as well. Prepare your terminal, easy follow along, that will make your brain get more ideas at the end on what you could do for your personal case. I left a link in the bio for students who want to learn AI by doing, beginner devs want to think out a service that they could offer, or business owners who want to use AI for themselves. It is free. There is a guide PDF to download and a video. Link is in the pinned comment or video description. Get it now from our hub, Shaker Houses. Also, please like and subscribe. Thank you for your support. Let's get started. Init containers. So here I'm just going to be creating a boilerplate. Okay, Tokyo 109 promo message. We create the pod. We change the label. We're going to use a namespace for that called department stores. I'm going to create the namespace after. So here what we are going to do, we are just going to create a custom message. But this custom message is going to be injected into the pod. Just let's see. I show you while I'm writing it. So we have the container. The image for the moment is busybox 1.35. The name, Tower 109 promo message. The volume mount is HTML 109 message, that's the name. The mount path, I put here user share Nginx HTML. So I might change the image to Nginx. Or just use another mount path. So that's the main container app. Let's do here the init container. That's the concept that we're going to start first with. Init containers. So let me just copy all of this under and call it init container so that we keep this image for the init container. I will change the mount path after. On this one here, we're just going to be calling it Nginx because the user share Nginx HTML, that's the mount path where you find the HTML page of Nginx. So here you're going to deploy your AI application. You want some different configurations to live in your environment before deploying the application. So you're preparing it. Here we're simulating it by just preparing a volume which is going to be handling this transformation of the HTML page of Nginx through a shared volume. As you can see, those volume mounts, they have the same name because they're going to be sharing the same space, where this index.html file will be shared between those two different processes. So one is going to be writing into it is the init container. Init containers always run before the main container, as you can see here in the indentations. One is called container, the other one is called init container. Here for the mount path, you can put whatever you want. Normally it's going to create it automatically. So department store 109 message HTML. The image I'm just going to use here BusyBox 135. That's the version. Init 109 HTML, that's the name of the init container. So the init container, the concept here is going to run first. When it's done running with all its processes, only after that the main pod container, the application, is going to run. So if the init container fails, the application will never be deployed. It's very important to know that. So here I'm going to be simulating this creation of HTML page with a custom message that I'm going to write to a file. That file is going to live in the mount path of the init container, which is department store /109/message. I don't know if I'm going to keep everything, but yes, /HTML. It's a bit long. So here I got a custom color just to match the April colors, Sakura colors. So the command here that we're gonna run is a shell command. I'm writing the message, but after I will add the echo, and after the echo is going to be pushing this message into an HTML page. So I'm just going to copy this path, complicated path. You can make it shorter. And here we go echo. Shibuya 109 is running a spring Sakura promo, all minus 30%. And we're going to write it to this in a file index.html. Okay, so it's a BusyBox init container. So after having run that, it's going to die. But this is the normal behavior of an init container. But later on, when we're going to use that, we're going to try to make it live longer, just to see what's going to happen. So the volumes have the same name, but doesn't mean they share the same space. And here we're going to create this link with a special option. So we call the volumes. That's normal. So here I'm passing in another terminal. We're going to call the volume HTML, the same name, and we're going to use mtdrs. Just pause the video if you want to see it. Here I'm just going to cut it so you can see HTML 109 message, the same name that we have. That's how they share the same space, but you get the option volumes mtdir with only with a curly brace, an empty curly brace, and that's how you're going to be able to share different space. Okay, So it has been, I've just tested it to check if it works. So here we get the pods, there's no pod deployed, I got rid of it. Okay, and I have the namespace also created. So in the default namespace there's nothing, but in the department stores namespace the pod has been deployed and is running. So now we can describe it just to see what's going on. Okay, has been affected to the node 1. The container image busybox is ready. Created the container. So it went okay. Okay, so init 109 HTML. Okay, has started. Created, started, and after the Nginx image. So everything went fine. So we're quickly running this init container so that we don't make this video too long. Just pause the video if you want to see what was in the terminal or the different elements of the config files. For the first one I won't stop and stay longer time on it. So here that's not, maybe I need to just expose it. Okay, so let's get the services. Okay, I just get the services in the namespace department stores. There's no service there. Let's use the expose command to create this service so that we can see if this Nginx message, if this HTML page has been updated by the Sidecar. Okay, here you are just telling to yourself you have a pod, an application. Before it runs, you want some configurations to be done. You're sharing the space through a volume. When the container is going to start, it's going to have access to that volume using the option empty dirs. And you're going to see if it has been able to read those. You could have used config maps, but here we're just using this in order just to simulate the utility of a Sidecar. Sidecars are used also for all the monitoring side and the security side of pods. Okay, expose the pod in the namespace department store. On port 80, target port 80, the type is of type node port. So yeah, it's port forward. No, it's not port, I think. Yeah, it tells me the options. That's what is good when you make an error. The output is getting better and better in Kubernetes. So now we can get those services so that we get the port in which it has been made available. Okay, Kubernetes is going to give you a port number, part of the upper band. If you want to set your own port numbers, you start at 30,000 and you use the lower band. Okay, you can curl or use HTML or use the browser. I mean, in the browser, when we go, we get it. Sakura 109 is running Spring Sakura promotions. Minus 30%. So don't rush there, don't go there, because this is a fake promotion. Okay, we got it now in curl, so everything works fine. So this is the introduction to Init containers. Please like and subscribe during the break. Activate future. Sidecar container. So I'm using the cluster version v1.28. So the sidecar feature is not enabled by default. Probably in the future versions it is. I've read that in the documentation, I'm not sure. So here I'm just going to show you what are the steps. In the controller node, you need to do some different steps, and in the worker nodes. So here in the controller node, we're going to create a boilerplate, kubadm config print init default. I'm going to push this boilerplate into a file that I've created called activate sidecar feature on cluster from boilerplate config file. I'll just give it a sentence. And here it's init defaults. There's a S at the end. So we're going to edit this file and add some different fields to it and update some other ones. So that's the part of the video. If you miss this part, nothing's gonna work if your cluster version is not having sidecar by default. So we get the nodes because we want the the controller node IP address. So here we got it. The name is controller.creditizens.net. We will need that. You go to this line number 12, that's what it was, but you just change the advertise address to the IP address of your controller node. This is mine, I have updated it. And after here, when it says node registration, inside node registration you have name, it says node, and you put the name of the node, which is controller.creditizens.net. Okay, so that's for this part. And after, for the other parts, we are just going to use the same kind of code snippet to activate the feature, which is called sidecar containers feature. Okay, so we go to different components, API server. In the API server, we're gonna add it. After, we're gonna do the controller manager, we're gonna do the scheduler. So here, activate sidecar, I just put the comments on the API server. Okay, I just write it here so you can see it also. Activate sidecar feature. So this is in the second part of the YAML file. On all different Kubernetes components. All, just only those three. API server, controller manager, scheduler. So we follow the indentation. After API server, there is a timeout for control plane. We stay in the same indentation. We're going to enter extra args, extra arguments. And here, future gates. And we're going to activate it here. We're going to put sidecar containers equal to true. Equal true between quotes. I'm just going to copy this, but that's what we're going to reuse in the other components. Here we have the controller manager. So same on the controller node. On the controller manager. So I'm not going to write it second time. Let's just get rid of the curly braces. And after you follow the indentation, okay, just copy and paste. That's what I did up there. Make sure it's indented the same way. And after we need to go down there, we have the same for the scheduler. Okay, add a little comment, same on the scheduler, and we paste. So now we're good. You need just to write this file to make sure it's saved. And after we can go in the terminal to upgrade, use the upgrade command on Kubernetes cluster, and we're going to be using the F option to indicate this file that we have just created, and this is going to be patching our cluster. We use the version of the cluster, the version of the cluster that we're using at the moment. So this is the boilerplate of the command that you need to run on the controller plane. Sudo kubadm upgrade apply your kubadm version, and after you use the -- config, so it's not the F, it's a -- config equal the custom config file you just created. Okay, so here the version, I can check it here, I can copy that kubadm version. So let's follow this boilerplate and get rid of those and replace with our version here. And let's replace this with the name of the file. So there's no auto completion. What was the name of the file? So maybe by putting a space I can find it. Let's put a space. Yes, I got it. So the name of the file was starting with a A. I should have just started with the alphabet. Okay, it doesn't autocomplete when you're on it. So I'm just going to go like that and get rid of the space. Okay, and after here you put your config file. It doesn't have to be that complicated, but you got it now. And after from here you can apply it to the cluster, like that. I've already done it, so hope it's not going to break everything if I do it again. But I'm not going to say yes here, but you're going to say yes, and everything is going to be fine. On the controller node, everything is going to be updated. Okay, but I have already run it, so just say yes, and after go to worker nodes. Okay, so after that we're going to go into the worker nodes to do the updates there. It's going to be a bit different there in the way we're going to do these updates. Okay, so let's go into the node one of the worker nodes. We're going to do those two. So you can run this command here just to check if Sidecar container is activated. So let me just show you here, for example, it's activated. You can check at the end on the controller node. So here I'm back into the controller node just to show you that you can check. So you check the processes, AUX, grep kubelet, grep side containers. Okay. Sidecar containers. And here we can see the feature is activated. So activate feature sidecar container on the worker node. I'll put the title just to not confuse you. So here we need to go into this folder, varlib kubelet. Inside varlib kubelet there is kubadm flags envs. We're going to use the environment variable and add the feature into this environment variable, activate it through that. So you go at the end before the closing quote and you add the future --future gates equal sidecar containers equal true. Okay, so same as we did in the file, but we're using here environment variables, so we're using the equal sign. We just check, has been recorded, it's in. So the worker node here is ready to make this upgrade. So for Kubelet to pick up on this future activation, we need to restart the daemon resec, and after you can just restart Kubelet. It might work if you just restart Kubelet, but just do those 2 commands, and after you check and it's activated. Okay, so Kubelet has picked up this future and has updated. So you're gonna put in the environment variable. Kubelet is a daemon set, so it's gonna be checking on the controller node. Controller node, it has been activated. Here is gonna be activated as well. We do the same process here in the node 2. Okay, I'm just gonna copy the future here, go there, open the environment variable in the file, update the file. So I'm using nano, it's okay. And after, I'm just gonna run those commands again, just to show you. And here restart Kubelet. And here we just check, yes, it's activated. And there is one last step to do. So here we're just gonna go and check the pods. See, for example, here Calico is having 3 init containers, but they're not running on the worker nodes. See, they're still blocked into the init phase. So what you need to do, you need just to delete those. They're daemon sets, so they're gonna be restarted with the future enabled. So those init containers will be able to run without any issues. Okay, we get rid of it, and we see now, not yet, it's not yet running. I'm just gonna delete the other one in the meantime. Has been deleted. And now you see init 2 out of 3. Let's run it again, just to check. Yes, running 0, 1, and after it's going to be 1, 1, and the ready state. So the status is running, they're not ready yet. And now everything is fine, it's back. So now you'll be able to use site containers. Please like and subscribe during the break. Let's check the special site containers. So we're gonna start with an example here. Still using init containers, but in a special way. So we're gonna build our boilerplate for this new example. Run Mangakisa Abunai, that's the name of the pod. Image nginx, with dry run, we put the output in a YAML file, which is going to be called the same way, Mangakisa Abunai. Let's edit the file. So we can get rid of these resources we don't need. Just make it like that. After maybe here, I like to swap this to have the name on top and the image under it. And respect the indentations. And here we're just going to put the app label. So what we have in this pod is a spec container, a spec init containers, and the spec volumes. So we're going to keep going here in our definition of this pod. Let's call this container proxy mangakisa. We're gonna attach a volume to it using the same shared volume. So the name of this volume mounts, just gonna use one. So the name will be shared Mangakisa volume. After the mount pass, we just use the normal Nginx mount pass, use a share Nginx HTML. That's where the index.html lives. The init container will have the name, image, command, volume mounts. And after here in the volume mounts, we're going to do the same. Create a shared Mangakisa volume. So we use the same name because we want to refer to the same volume so that it can be shared between the two containers. So here, little typo, volume. And here, mount path. For the mount path here, we put whatever we want. It's just going to be created. Mangakisa events. So in terms of name, I'm going to call it Mangakisa events. Just going to use a BusyBox image. We're going to run a command. And after here, we can also chain all those arguments, all those different commands that we want to run. Let's respect the indentation. And here you just enter your shell commands. I use different ways in different YAMLs so that you can see how it can be written. If there's no typo, there's no errors. So you won't come back to it. But yeah, here you can write comments. Use the list and put inside sh with the option -c, and after use the args down there to have a kind of list of arguments. So the first, I'm just making the directory. We don't need to make it normally, but you can do it. Make the directory that you want to make. For example, here for the volume, and after here, so you can just put a script under that, line by line. Echo running from init container. And we're going to customize that index.html page of Nginx, and this message would show that they are sharing volumes. So here the init container would be writing this message. On the index.html page, and the container, the proxy MongoKisa container, would be accessing that kind of config file. That file. After you can just imagine whatever you want for that. There are different ways of using that. You can use it to have some monitoring on the side also. So not with an init container, but the way we're going to use init container here, it's possible to do that as we're going to be transforming this init container. And I'll show you that when I'm done with this little message. Okay. So I'm trying to change the examples from what I've done by myself alone before running this video. So I'm checking my notes sometimes, and yeah, you're gonna see some errors happening. It's better to have those kind of tutorials with a little bit of errors, so that you know what is a typo error and you know what is a functional error, because of the logic and how the underlying components of Kubernetes works. And what is required to add. So here we got the shared volume. We use the option mtdir. That's how you do for the volume to be shared between the container and the init containers. So now we are going here, I say now let's add the very important option that would change this init container to a long-living side container. Because you know init containers are just doing their job, and after they die, and when they're dead, they finish doing the job, like here writing to the file system. That's when the container is gonna start. So the main application container. That's how the main application container would be able to use the environment set by this init container, or the config files, or anything else. But here, the lifetime of the init container is going to be same as the pod lifetime. So it's not going to die. So this init container with this restart policy always. So using the always or restart policy makes it become a side container. So now we're going to try to apply this to the cluster. I'm just going to show the file again. Okay, we try to apply to the cluster. If there's any errors, we're just going to go back to the file and fix it. Okay, so just going to open another tab. I want to be able to watch what's going to happen on the side. Get pod wide, use the watch command. Okay, I still have this one running. Might need to delete this. So let me delete this one. Okay, so the cluster should be cleaned. There won't be any more pods. Yes. Now we start with our fresh cluster without any pods, and we can run this example as a standalone example so that we can see what's the behavior of Kubernetes. Okay, pending. After we enter in the files init, pod initializing, pod running. Okay, so in the process we didn't get any error. Okay, got everything fine. So this is a scenario that can happen to you. Everything looks fine, is deployed, everything is running, but is the environment correctly set? So we're going to describe the pod. Mangakisa Abunai is on the node 2. Okay, label app Mangakisa Abunai. We have the Mangakisa events. This is the init container, which has become a sidecar container. So for that, to be able to do that, you need to activate the future gate sidecar container that we did before. This is the message. State is running, you see? So it's not dead, it's living with the container. I use just sleep 3600 just for the busybox to not die, because it's meant just to run commands. It's just a simulation that we're doing here, and we have those mount volumes, read write. Here same shared Mangakisa volume, read write permissions, and the volumes which are here declared with an empty dir, a temporary directory that shares a pod's lifetime. So here the init container also shares the pod's lifetime by adding the restart policy equal to always on the init container. So this is one way to do a sidecar container, to get one container on the side of your main application, which is doing some work. You can also create the sidecar containers in order for you to be able to go and check what's going on in the application, because you have more tools in that little container installed. So here I'm just going to expose the application using this service. I'm just going to check if the message has been written correctly to the index.html file. And boom, you see here 4.3 forbidden. So everything looks fine, but it didn't work well, because here the commands didn't return any errors, because this is just a normal command, but the file doesn't exist. So we need to add here index.html. So if we don't get this index.html, the index.html existing on the user share nginx.html path of proxy Mangakisa container, it won't be updated. It won't be patched somehow by our new index.html file. So I'm just gonna delete the pod. You can use here the flag force, -- force, because I noticed that when there are some init containers sidecar containers. It takes more time to delete. So you might see me using force later on in the video. Here I'm just going to wait. Not going to disturb it. It's done. It's going to do the job. And let's reapply it again to the cluster. The service has been already created. We didn't change the label, so it's going to be able to pick up on this pod. Okay, you see here init phase, and now it's running. Okay, you can check the service if you want. And the service here is still available, so we're going to use the same port, and here we expect to see our index.html message. Yes, so everything is fine here. So in Firefox, in the browser, we can just see the message and the colors are applied. It's a bit slow. That's my computer. It's like that. Manga kisa, mecha kucha gucha, abuna yo. Okay, so running from the init container. So this is one way to create a sidecar container. I'm gonna tear everything down. So here you're gonna use the first concept that we've seen in the first part of the video, init containers. After, you need to use the second part of the video where we have activated the FutureGate sidecar container. If this FutureGate is not activated, by default you need to activate it by yourself, doing the way that I showed you if you have a Kubernetes cluster. And after that you'll be able to subscribe and like. Normal sidecar containers. Okay. So same here, same concept. We're going to be creating a file that I called Tokyo Tower Sidecar Info. And we're going to create a sidecar container the normal way. One container is Nginx, simulating our main application, while the other container will be the helper container on the side, or the tooling container, security tools, monitoring tools, any tools that you want to have available, or for the admin, or for the DevOps, or for the site reliability engineers, or even for the application itself, because they're sharing the same network. So they can access to each other's. You can use the shared volumes for that also. So it's very interesting to use site containers. So basically it's a pod having more than one container. So we have here containers. Inside containers, we have Nginx, the image Nginx, volume mount, info message. So in this one here, you won't see me writing init containers, for example. There won't be init containers in the normal site container configuration. But instead of having only one container in the list, we get the second one here. And that will be what is called the sidecar container. Info of the day. Using the same concept here, writing to a file. I'm going to use BusyBox 1.35. I'm going to run a command. So before you've seen we've been running a command. The command was not returning any errors. So everything was running fine from the outside. But while checking the runtime of the application, while trying to curl to the application, we've seen that we got an Nginx error page displayed because we shared the volume empty dir. So the directory was empty. There were no files in. So automatically Nginx felt to its 403 or 404 page. Tokyo Tower will be opened on April the 1st, and this is not a joke. Just put a little message so you do your own while following along. After here, I'll see if I'm just going to use a path, but I see if I use sleep or if I just tell a file so that BusyBox container stays alive. As I told you, BusyBox containers are meant just to run commands. They're not long-lived containers normally. But there are tricks, like here, we use tell f dev null. So here, no need to use any restart policy always. It's not mandatory. While in the example before, it was mandatory to use it. There are different restart policies, values available, but only the always one can be used in conjunction with an init container if you want it to become a sidecar container. And this feature is enabled only if sidecar container feature-gate is enabled on your cluster. Okay, so here we just put them on path, put info, Tokyo Tower info, and let me just add here also info. And now we just need to add the volume, which is going to be of type empty dir, and we just give it the same name, which is info message. So I'll redo everything at every single example for the people who jump from one timestamp to another in the video. But in this video, if you have missed the previous part in which I have enabled sidecar container, you're missing an important piece because nothing is going to work if you jump to this timestamp directly. Okay, so we got the file. You see everything is indented under the containers. We have two of those. One is a sidecar for us, and the other one is Nginx, our main application. But if you exec, kubectl exec, you have access to both. Okay, it's created. Let's see what's going on. Oh, we got an error. Running 1 and 2. So when you use containers like that, both containers are created together, not one after the other. At this time you get so here we've seen 1 out of 2. We're just going to describe the pod to see what's going on, because here we have access to the 2, and here we see the state is terminated, an error state for the info of the day container, which is the BusyBox container. You can check the logs. The logs is empty. Okay. So there is something wrong. So is it about the path, mount path? Is it about the command? The issue here is that when you get this kind of errors, you need to debug yourself. You need to have experience. Let's say here that the problem was maybe the syntax that I used. Maybe there was something wrong about it. We got the index.html. We doc to dev null. Okay, nothing wrong here. Let's delete and try again. So let me check the logs again in details. I've been quick on it. So here it says, okay. So the problem is on that one. So even if I swap, it's not going to change anything because they create it together. But I'm going to swap it so that you can see. I got rid of the pod. There's no pods anymore. Okay, it's back in the cluster. Let's watch. What's gonna happen now? It should work now. No, it's not gonna work. The order doesn't matter. The syntax was fine. Maybe it's another detailed syntax error that we've done. So that's when you need to be careful and check. But what is good here is at least we get an error message, not like the example before, telling us that everything is fine. So we redescribe. I've changed a bit the sentence, but it's still the same. Okay. So there is one tiny error that you can spot from here normally. Just check out the command to give you a hint, and you will see that there is something missing in the command. Okay, around here. So the state is terminated, there is an error because there's an issue with the shell command. Let's put back what we had before. Here, -1, the stars. Okay. And here, just let me get rid of this using nano. And this is the main error. We forget the dash at C with the option for the command. You see, just one tiny error like that can just make you crazy, doing some changes everywhere. So we're going to get rid of the previous pod. So now what you need to understand from watching that is that when your sidecar container doesn't work, the pod won't work, even if the other container is running fine. Okay? Same for the init containers. If one of the init container has a failure, the whole pod is gonna fail. Okay, so now we have the normal process. Don't have any more the bash command, the shell command being blocked, and now it's running. But yeah, we got that before. It was telling us it's running fine. But do we have access to the runtime of the pod? Is the runtime showing any errors? Let's just describe first. Okay, it's on the node 1. Status is running, so there's no failure underlying. All the containers are running. BusyBox info of the day is running. The command has the dash on the C, which has fixed the error. Nginx is also here. Everything is fine. They're sharing this volume. Okay. And let's see for Sidecar container, which is just running, means it's going to leave with the pod. It's not going to die out. If it did its job properly. So I'm going to label the pod so that I can expose it as a service. Neighbor Minato, one of the Tokyo neighbors. And we're going to expose the Tokyo Tower sidecar info. Tokyo Tower is not in Minato. Neighbor is in the other side of Tokyo. But I like Minato, so that's why I use that. And here we go for port 80, target port 80, type not port. Same as we did before. We exposed, you pause the video if you want to see the comments, and you run those on your cluster. It's good to play with the names so you understand which names you can change, which are working together. And we got our message here. So we don't need to go into the browser. Okay, and now we can tear everything down. I use the force flag here to get rid of it very quickly. I know what I'm doing. We have seen init containers and how they run before any container pods. We have seen that init containers can become sidecar containers, having same lifetime as the pod, but the cluster needs to have a sidecar feature enabled. This depends on your cluster version. Mine was 1.28, but after this version, I believe that the new ones, they have implemented it as a default, but still check if you need to activate it or not. We have seen how to create a normal sidecar container, living alongside the main container of your app. Nginx is amazing as it helps to abstract away some stuff and still be able to use a local cluster with limited resources and see all those concepts without burning money on cloud Kubernetes. Keep going, guys. We keep going and we will see some other concepts soon. Prefer hands-on so that you get some errors, and use ChatGPT to fix those by asking hints but no answers, and use the documentation to get those answers. Interesting, isn't it? Okay, let's stop here. Hope that you like this video. Please like and subscribe, and see you next time.